Hi, welcome to the next little instalment of my solar accumulator project. I allowed it to go completely flat so that I could get an idea of its charging capability. Unfortunately the weather hasn't been very helpful and it's done nothing but rain, but today the sun has come out it's just visible through the clouds. So I've got here some solar panels. These are 25 watts each, these two. These are 20 watts each, so the combined is 50 and 40, total of 90 watts. The solar accumulator was completely flat. Actually it was showing 7.8 volts, so it had gone pretty low, pretty much down to the BMS shut-off voltage. But it's been on charge for 15-20 minutes. We are currently showing 9.34 volts and a charge current of 2.6 amps, which I don't think is too bad considering the small size solar panels that are on it and the very poor sunshine that we've got here at the minute. In the box here, come all the way from China, although pretty quickly, arrived in about 8 days, which was surprisingly fast. Makes me wonder if it came from a UK or European warehouse somewhere. But it did have a customs declaration on the box. So this is a shunt version of the panel meter. The one that's in here uses an inductive pickup, and I'm not happy with its accuracy. It seems to be quite unstable. You move the thing around and it alters its charge current. I also had to modify it to make it work right the way down to 9 volts, because when the battery voltage was 9, this display unit here was showing about 11.5, and as the battery voltage climbed up to around 11.5, it started showing more accurately, which is just irritating. I did do a little fix which basically links out the high voltage power supply, but the voltage is now correct, but I'm still not happy with the way it reads the current. So the idea is to use a more conventional shunt type current meter. So this shunt is designed for 100 amps. It also has a temperature input on this one, which the other one doesn't have. It uses connectors for the outputs, the relays. The other one uses screw terminals, which I don't like, and the battery connections are big terminal posts and this small little one here. So with the exception of the very short wire, which is about 4 inches or 5 inches, I'll have to extend the wire, but this one should be more accurate. I've actually put it on my bench power supply, which is fairly accurate. It's within about 1%. Set the voltage at 12 volts and calibrated this so that it shows exactly 12 volts when my bench power supply does. I've then cross-referenced that with a known good DMM, and the voltages tally up. This is 0.02 of a volt different, which is accurate enough for this particular use. So there we are. I shall update a little bit more once the sun is shining. I've still to put the high current input, which will have an 8 amp input capacity, and then this thing here will go in, and I shall do an update once I've done that. Thanks for watching.